Hi, I'm Ted Haberman from Metadata Game Changers, and I want to talk to you today about data journeys through the global research infrastructure. All the data journeys that we're going to talk about today begin with researchers. And in order to be connected to those data journeys, the researchers have to be identified. And the most common identification that we use for researchers these days are ORCID IDs. So we start the journeys with researchers with ORCID IDs. We're going to focus today during the first part of the talk on data journeys that involve the National Science Foundation, the U.S. National Science Foundation, I'll refer to as NSF. Two data journeys that are directly involved with NSF are the NSF Award Search and the NSF Public Access Repository. We're going to compare those two during the talk. The third one that we're going to talk about is Chorus. Chorus is a tool for searching and aggregating data from across the what we call the global research infrastructure. So it's really made up of organizations that create and identify or create objects, create research objects, and identify those and store metadata about those objects in a number of different systems. Primarily in this case, Crossref, DataCite, and we mentioned ORCID for researcher IDs, and Scholar Explorer for links and links between things. There are also a couple of important organizations involved in that global research infrastructure that we're going to look at, publishers and institutional repositories. So these are the three data sources and the three data journeys that we're going to talk about in this talk. The first is an NSF Award Search, and the NSF Award Search data journey is short and sweet. Researchers submit proposals to NSF. Researchers with identifiers submit proposals to NSF. NSF gives awards to some of those researchers, and then once that happens, and NSF adds those awards to the award search. The work that we're going to be talking about today was funded by the National Science Foundation through an award whose number is here, and so if you search for that award number in the award search, you find it. We're also going to be talking about data journeys that come from, the idea was developed by Bates et al. 2016, so there's a reference to that paper here. because NSF gives awards and they populate and control the award search, we assume that the coverage for awards in the NSF award search is 100%. All of the awards are there. The NSF Public Access Repository, or PAR, the data journey is more complex. Once researchers create outputs, they receive an award from NSF. They create outputs based on that research. They identify those outputs, and then they submit them to NSF using a PAR interface. There's also a backdoor into PAR with Crossref, through Crossref. We're not going to talk about that one today. But anyway, because this journey is a little more complex and involves a number of researchers interacting with a system through a user interface at certain times, we don't really know what the coverage is in terms of research outputs in PAR. It's different than the award database where we assume that the coverage is 100%. The global research infrastructure, as viewed through Chorus, is by far the most complex data journey that we're talking about today, and it's shown. Some aspects of it are shown in this fairly complex picture that we're not going to go through. There is a reference in the notes to a blog post that describes this in more detail. but Chorus presents, or Chorus creates reports in analysis, what I would call analysis-ready data from the global research infrastructure, and we really focused on 3 of those in this work. The all report on the bottom is all metadata, mostly cross-ref metadata about papers. The author report provides information, affiliations, and identifiers for authors of that work when they can be found. And the dataset report provides information about datasets that are created. Notice that this data journey starts on the lower left of the figure with a query against Crossref. That's going to be important. The other important thing about the global research infrastructure, because of the complex data journey, we don't really know what the coverage is, and comparing coverage across these 3 different sources is going to be an important part of what we're talking about today. But like PAR, we don't actually know what the coverage is in the global research infrastructure, and we'll talk about why that is in a minute. One of the important things about the global research, about the data journey for the global research infrastructure, is that it is complex, but it's also well described in various parts of the Chorus website, but it's also reproducible. We know what the steps are. We can execute those steps ourselves and understand aspects of them. But it's also important that the sources and the processing change as a function of time. So we can reproduce it, but we can only reproduce it at a given time. So as an example of that, I mentioned a couple slides ago that the Chorus data journey starts with a query against Crossref for research articles that are funded by particular funders. Chorus offers also some other searches of institutions and journals, but we were focused on their funder searches here. So looking at Crossref, between 2002 and 2023, the number of articles per year processed in Crossref increased by about 3.6 million, a factor of 4. So right now there are about 10 articles every minute processed into Crossref, which is quite a task. The percentage of these articles with funder metadata has changed considerably over time, and thankfully it's increased quite a bit since 2014. But even with those increases, about 80% of the Crossref journal articles do not have funder metadata, and so they do not make it into the global research infrastructure data journey that we're discussing. It's important to remember this sort of always throughout this work, that there's a large collection of unknown unknowns that we don't really know about using this source of Crossref funder metadata. So NSF awards, as I mentioned, Chorus provides information, data about NSF awards, and in the example that we looked, or the data that we looked at, there are about 233 publishers that have published a total of over 400,000 DOIs, primarily in this case research journal articles that were funded by NSF. 366,000, just over 366,000 of those have awards, 89%, which is really great. But it does leave 46,000 without award metadata. So obviously awards and funders are 2 separate things. Awards are are interesting, are higher resolution, but there are quite a number of journal articles in the data set that don't have any award information. It turns out that of the 233 publishers, 151 of them have awards for 100% of their articles. So this is really great. I mentioned earlier that publishers and institutional repositories both have important roles in the research infrastructure. And one of the important roles of publishers is to get funder metadata from researchers, another important player here, obviously, and to interpret that metadata and add it into the metadata, or interpret that information from what the researchers give them and get it into Crossref in a structured form. So 151 out of 233 do that very well and consistently across all of their articles, which is great. 52 have award metadata for over 90% of their articles, which is, again, pretty good. And 30 have award metadata for less than 90% of their articles. So that's about 13% of the journals that we're dealing with here. And it's important that, getting this funder metadata into the metadata for these articles, as I mentioned before, really is a partnership between researchers and journal publishers and journal submission systems. So it's important for researchers to make sure that this happens correctly. And it turns out that most of the articles that are missing awards, 83% of them, are only in 4 different journals. So the target for improving these partnerships that I mentioned, the target is pretty small. We can do pretty well by just improving processes and interactions with only 4 publishers. So we talked about awards a little bit, and now we sort of understand some of the challenges of getting awards. We now want to go to another step in sort of the higher resolution, looking at DOIs in Chorus and PAR. Finding DOIs associated with awards in Chorus is straightforward. Finding them in PAR is a little bit more difficult because there is no API there's no easy way to get large amounts of data out of PAR. So we had to find a way or create a mechanism for getting that information. And so I'm describing the steps of what we did here. We started in Chorus, and we query Chorus for the DOIs associated with the award. Actually, we downloaded data from Chorus, and then we searched it, as a CSV, searched it for award numbers. In this case, the award number 1314642. And in Chorus, that award number has 26 DOIs associated with it. These are journal articles that were funded, that acknowledged that award in their acknowledgments, and that was picked up by Crossref and Chorus. In order to find out whether those DOIs are associated with that award in PAR, we need to run a query for a query that combines the award number and the DOI, and we can query PAR to find out whether those two items are associated with one another in PAR. We do that by looking at the response length of the HTML that comes back to that query. That HTML has sort of a header and a framework and a page that comes back saying that in this case, saying that the data are not found. So if less than 226,000 bytes comes back, that means it's just this header. If there is an association between these two things, if this DOI is in PAR and associated with this award number, the response length comes back with information about that award, so it's bigger. So if it's larger than 226,000 bytes, then that award and DOI are in par. So of these 26 DOIs that were associated with this award in chorus, 16 of them were only in chorus. They came back with only the less than 226,000 bytes. 8 were in chorus and par, and 2 were only in par. So for this case, looking at the comparison for this award number, we can see that there's information in par about 10 DOIs, but in chorus there's information about 26. Quite a bit more. If we look at the bigger picture here for a sample of 51,000 awards, rather than just the one that we showed in the last slide, we found that of those awards, 32,543 of them had information in par, so they show up in the chorus. They were also in chorus. That's where we got them. But 32,000 were in chorus and par, and 19,000 were just over 19,000 were in chorus, but not in par. So there's quite a large number of awards that make it through the chorus data journey, but do not make it through the par data journey. The same is true for DOIs associated with them. Those 51,000 awards, we found DOIs in core. We found 127,218 journal articles that were in chorus and par, and 180,000, just over 180,000 DOIs associated with these awards that were not in par. So comparing these data journeys, and other things that control what data goes where in this example, it's clear that many more things make it through that global research infrastructure data journey, even though it is more complex than the chorus. It's complex in a different way than the par data journey. And of course, one of the reasons that we're interested in this is because those articles provide a mechanism for NSF to estimate or quantify in some way the impact of the funding that they've provided, and it seems like we could augment that fairly significantly by integrating data from the global research infrastructure into that impact assessment. So if we look at this as a function of time, this is a stacked bar plot of the percentage of DOIs that were found in various systems, and the blue are chorus only, the green are chorus and par, and then the gray are awards that were awarded but were not included in our sample in this case. And it's clear that in 2017 there was a significant change in the percentage of these awards or the percentage of these DOIs that were found in chorus and par, a big increase in the DOIs that were found in par, and that corresponds to a change in the NSF requirements with respect to par, and they started in 2017 requiring submission of research outputs that occurred during the time of the award into par. So that this picture really sort of emphasizes the observation or the feature that part of data journeys are technical and they have to do with formats of data and transformations of data and processing of data. But part of the data journeys, another important part of the data journeys, is the policies and the values and the actions and systems in the organizations that participate in that data journey. So here we have a great positive impact of an NSF policy and a change in that policy. But now we want to think about what do these differences really mean in terms of how research articles and awards make it through the data journeys. And so this is a picture of all of the awards in the award database between 2004 and 2021, and where and when references to those awards occurred. And there's 4 different sets here. Blue is chorus only, so these are references to awards that were only found in chorus. Chorus and PAR are green, 6% here, are in both chorus and PAR. 16,000, almost 17,000, or 8% of these are in only in PAR, and 56% were not referenced anywhere. Well, what does that really mean in terms of the data journeys? Well, chorus gets information from Crossref, and so items in journal articles in Crossref are generally peer-reviewed, and so everything here in chorus, the blue and green groups, was peer-reviewed and published in some journal. PAR also requires or limits in the NSF policy, limits things that go into PAR to things that have also been peer-reviewed and published. So all of the things in the blue, green, and yellow slices here have been peer-reviewed and published. In order to make it into Crossref, it means that the funding is acknowledged in the journal article, and it's acknowledged in a way that can be interpreted correctly by Crossref. And the yellow things that are in PAR, because they're in PAR but not in chorus, it means that they were not acknowledged in Crossref in a way, or not acknowledged in the research in the articles in a way that Crossref could interpret correctly, or could interpret. So once again, this gets back to sort of the relationship and the partnership really between researchers that are acknowledging funding in papers and submitting those papers to a journal. They need to make sure that the metadata that or the information that they have in the article about acknowledgments makes it into Crossref. It's also important to keep in mind here that 50% of these awards were not published, were not found in Crossref or in PAR, or in chorus or in PAR. So they were either not published, or there was nothing published, nothing that was funded by these awards was published, or if it was published, it was not acknowledged. Quite a large percentage. So we saw in the last couple slides ago that things changed as a function of time. So this is a plot of awards that were effective in 2014 and how they were referenced through time during the 7 years after, up to 7 years after 2014, so up to 2021, and the same colors that we saw before. And so back in this time, which is before chorus, or before PAR, the early days of PAR here, we can see that chorus, the global research infrastructure, really dominated this picture. and even 7 years later in 2021, most of the awards effective in 2014 showed up in chorus, a few in chorus and par, and not really very many only in par, and also still 41%, even after 7 years, were not acknowledged. We can look at these, the same results for awards with effective dates up until 2018. Our par data went through 2021. So in 2018, many of these awards awards that become effective or are granted in 2018 would be finished by 2021. But we can see really a significant change in these pictures. The percentages in par only are shown in these slices when they're above 10%, and we can see that for awards in 2017 and 2018, even after only 3 years or 4 years, many of those awards are showing up in par and or in chorus and par. So this again shows the success of or indicates success in the use and the compliance with NSF requirements, I guess, to put things to submit published research results to par. So that's great. That's a good example, and it clearly is a big difference between awards in 2014 and through 2018. If we look at 2021 as 1 year, of course, the year 2021 is sort of on a slanted axis here, or axis in this plot. But if we look at that just in 2021, the difference that we saw in the last slide really shows up in a different way. The blue boxes here are the percentage of references which are only in chorus, which decreased significantly through this time period, which is great. Chorus and par, quite a large number of things that are in chorus and also being identified or being referenced from par. Good stuff. The yellow slice is par only. It's also gotten quite a bit larger. And the interesting thing, remember, about these articles is that they're somehow published, or they're published and they're peer reviewed, but they're not acknowledged in chorus. They're not acknowledged in the global research infrastructure. They make it into par through that data journey, but they don't make it into the global research infrastructure for some reason. That's one of the unknown unknowns. And also there are over 30% still even remaining in 2018, or in awards effective in 2018. There's still over 30% of them that aren't referenced. And we don't really know what those are. It's easy to speculate that some kinds of awards, well, it's certainly true that some kinds of awards made by NSF may not produce published results, but we restricted our data to standard continuing and fellowship awards granted between 2004 and 2021. And so we sort of expect that type of awards to produce some results, or some published results. So that's sort of the end of the NSF story today. And we want to now talk a little bit about destinations as some other pictures, some other data journeys. The goal of all of this work is the PID graph. It's the connected graph of all kinds of things with identifiers and relationships between them that make up this graph. So this is sort of our goal that we're trying to create here, or we're trying to understand and create in a way that we understand. So the other, once something gets into the PID graph, how do we find out about it? This is a picture from DataSite Commons, and DataSite Commons, sort of like Chorus that we talked about. Remember the data journey for Chorus was fairly complex, and it included DataSite and Crossref and ORCID and other sources. In this case, DataSite Commons is a similar thing. It includes DataSite, Crossref, ORCID, ROAR, and event data, which is an interesting set of data things. So it's a different data journey, yet another complex data journey. And in this case, the National Science Foundation of Sri Lanka, this is the Commons page for Sri Lanka, which shows almost 11,000 works. And the National Science Foundation of Sri Lanka, as we'll see in a minute, is interesting because its acronym is NSF. And many people, when they're acknowledging a funder, when they put in the name of the funder, certainly many researchers in the United States who are funded by the U.S. National Science Foundation write NSF, and that's what we think when we hear NSF. But in fact, the National Science Foundation of Sri Lanka also has the NSF acronym, so it gets selected in some we don't really know how, but in some automated system somewhere along the data journey, an error is made because of an ambiguous acronym. And so if we want to study this trying to find out where in those data journeys this error is made, we want to compare them. So in this case, we're comparing the Commons, which we looked at here, to Crossref, because most of these things are more of these things are journal articles than data sets. And so this shows the number of records with funder metadata in Commons versus the number in Crossref, and this with a line of equality shown going across this plot. And out of the almost 11,000 research outputs, essentially half of them have the same number, and the same number of funders mentioned in Crossref and in DataSite Commons. So that's good. There are more funders in Commons for 1,400 of these research outputs, and there's more funders in Crossref for just over 3,000 of these things. So this is the kind of comparison that we can make to try and understand where along the data journey certain things happened. In this case, we still don't know this, and part of that is because of I mentioned earlier the time variance. The occurrence of this has, we think, some dependence on time, although it's certainly long-lived. So another example comes from taking a look at over 400 researchers from the University Consortium for Atmospheric Research, UCAR. This is similar to the last plot. On the y-axis, we have the number of items found in the ORCID profiles for these researchers. We talked about ORCID before as an identifier for people, and ORCID profiles list works that get added to those profiles either by the researchers themselves or by organizations that they authorize to make those additions. So that's one set of data journeys. And then we know that the DataSite Commons, we talked about that. The data journey for DataSite Commons is a different thing, more like the Chorus data journey that we looked at before. And here it's fairly clear that most of these 400 researchers have more works in their ORCID profiles. They're above this line of equality compared to those that have more works in DataSite Commons. This is a strong difference between these two data journeys, and we're not sure at this point how it happens. but we think that it has to do with orchids being in the metadata. In order for things to get into Commons, Commons uses those orchids to make connections between things. Remember, it's a tool that sits on top of the PID graph, so PIDs must be in the PID graph in order for Commons to find them, whereas items can be added to orchid profiles by researchers without having the orchid in the metadata for the thing. So there might be a data set or a journal article where it could be 10 authors, and only in many journal articles only one or a small number of those authors have orchids. And so, but the other authors, sort of between number 3 and 10, could add those items into their orchid profiles without there actually being an orchid in the metadata. So that's another example of a data journey that affects results. And the clear solution to this problem, or an approach to solving this problem, is to do what we call recuration of this metadata. So recuration is the process of adding information to metadata records in repositories after they've been submitted. And actually, UCAR is working now with their data set records, which there are quite a few of, to add orchids into those records. And in that case, those spots, the dots for those researchers will migrate to the right, and we'll get closer to the desired result of having the points on the equality line. In other words, having data sets that are independent of the data journey. We talked a little bit earlier about the National Science Foundation of Sri Lanka, and it's a little bit different than the sort of existence of orchids in metadata or or not in metadata. In the National Science Foundation of Sri Lanka case, this is an error, and it's an error that has to do with the translation of the acronym NSF into the name and the identifier of the funder. So this is a number of publishers that we found in the chorus data set that we talked about earlier, who have this funder ID, which is the funder ID for National Science Foundation of Sri Lanka, and they have a funder name of either National Science Foundation or NSF. And that's over 6,000 records. And remember that we know NSF is the acronym for the National Science Foundation of Sri Lanka, and also for the National Science Foundation in the US. Unfortunately, National Science Foundation, the name that we use for that is ambiguous, not quite as bad as the acronym. But the important thing here is that this is an error across many publishers and also data site repositories. So it exists in journal articles. It also exists in data sets. And the solution to this problem is also recuration, and that identifier, the funder identifier, needs to be changed to national science, the identifier for the U.S. National Science Foundation, and that will correct this error. So once again, finding errors, finding omissions, as we talked about in the last slide. Both of those things are things that we can do to try to improve the metadata that we're using to try to drive discovery and various other processes. And of course, the obvious question is, how do we know this was supposed to be NSF, the U.S. National Science Foundation, rather than Sri Lanka? If you look at we know that most of these things we know that most of the journal articles in Crossref that have funder names also have awards. I think that was around 90%. And if you look at the structure of those award numbers, they are clearly, they have a structure which is consistent with the structure of US NSF award numbers. So in a large number of these cases, we can use that fact to support this this assertion that this is the U.S. National Science Foundation. And you can also then use the NSF award search for other award numbers, or for those award numbers, to make sure that that those are actually valid NSF award numbers, and also that the investigators, in many cases the investigators on those awards, would be the authors of these papers. So you can nail this down from a few different points of view. So the recuration process that we've talked about is an important one, and it's important for us to think about these repositories in the global research infrastructure as things that evolve as a function of time, things that improve their quality as a function of time. And we think about that in terms of a process which is called continuous improvement. We've looked at a number of repositories in DataCite defined to measure completeness in various ways of those, and identified a few repositories, a few DataCite repositories that have gone through this process of iteratively increasing improving the completeness of their metadata by adding various kinds of identifiers and other metadata elements. So this is something that is actually happening, and finding those repositories that are doing this well and recognizing them among their peers is an important part of this continuous improvement process. So looking at these data journeys, we can maybe provide some useful travel tips for participants in the research ecosystem to think about. For researchers and institutional repositories, we need to try and maximize the benefits of the global research infrastructure with complete, consistent, and well-connected metadata. Remember, the researchers and the institutional repositories and the publishers are really involved in the input, in the collection and submission and input and quality control of the metadata in those repositories, so they have a huge important role. Repositories, in fact, or in specific, need to choose tools that include the capabilities to update metadata rather than just submit it, so the new connections can be identified and added to the metadata, so that the tools that the repositories are using support this idea of recuration. And we all of us need to try to measure metadata completeness or consistency or other quality characteristics of the metadata as a function of time, recognize bright spots, those organizations that are doing well, and share their successes. We have a few blog posts that have done that for DataCite, and we're working to expand the breadth of those. But they're out there. We need to find them and thank them and learn from them, so that we can all the repositories can improve their metadata. And that's the last slide. Once again, this work was funded by the U.S. National Science Foundation. That's the roar of the U.S. National Science Foundation here, and the award number. And please contact myself or Jamaica if you have questions or answers, and we would be happy to talk to you about applying some of these ideas to your situations. Thank you very much. I hope you enjoyed the talk, and have a good day.